Hello world, welcome back to another TryHackMe challenge video. In this video, we're going to be going through the hacked room. Let's get started. So we jump immediately into the questions basically, and our scenario looks like it's covered by the first statement here. So let's go ahead and read that off. It seems like our machine got hacked by an anonymous threat actor. However, we are lucky to have a PCAP file from the attack. Can you determine what happened? Download the PCAP file and use Wireshark to view it. Alright, let's do what it says. Let's go ahead and download the task file, and we'll just go ahead and open it straight up with Wireshark. And now that we've got it open, let's go ahead and complete that task. Alright. First official question. The attacker is trying to log into a specific service. What service is this? Well, right off the bat, I see here port 21, right, is frequented a lot in this first section. And then, oh, I'm seeing a lot of user stuff here. It looks like some login stuff type deal, right? But we can go ahead and just look at the conversations real quick. Okay, so it does look like it's mostly port 21 and a little bit of port 80 down here. All right, and it does look like it's only between two IP addresses. So one's going to be our attacker and the other one is going to be our target, right? Or the victim. And if we look closer, looks like .147 is calling out to 115 through port 21. So it does appear that our attacker is .115, I think. Yes, it does seem to be the case. So, because these are ephemeral ports, so that's most likely the host that's being targeted. That's kind of how you can tell which one's the victim versus which one's the attacker, right? So keep in mind that .115 is the attacker and .147 is the victim. All right. So now we can take a look at the protocol hierarchy, and we'll notice, yes, FTP. And then for those of you who don't know, FTP is port 21. Anyways, so we know that basically it looks like most of the communication is happening over port 21, and we know that to be FTP. So let's go ahead and type FTP as our answer, right? Because that's going to be the service that the attacker is using to log into the victim from what we saw in the conversation history as well as the protocol hierarchy. There is a very popular tool by Van Houser which can be used to brute force a series of services. What is the name of this tool? So all we need to do here is simply just go to Google, type in Van Houser tool, and it's Hydra. Now what Hydra is basically just a way to automate logging into different services such as, like, you know, HTTP, FTP, SMTP, like it supports a bunch, and we can actually click here and see all the protocols it supports right around here, right? So you can see all the different protocols that actually will try to hack into, or sorry, that it can hack into, right? And that's the uniqueness behind it, because you can find tools that do it for individual services, but Hydra is by far the one that supports the largest number of services that it can try to log into, right? So let's go ahead and type in Hydra. All right. The attacker is trying to log on with a specific username. What is the username? Okay, I believe if we just scroll down here, I think we saw it earlier. Yep, it looks like the user is Jenny. And we know that these are FTP packets because it does say FTP right here. And this is what it looks like when it tries to send a user login over the FTP protocol, right? Submit that. What is the user's password? So if we scroll down further, we'll see that there's a bunch of passwords being tried here. And we'll also see login incorrect, right? Okay, so how can we determine whether there was a successful login? Well, we know from previous videos, right, we can do the protocol, FTP, and then we can do contains, right? Because it's gonna look for within that packet a certain set of data that we specify, right? And we want to look at for maybe login success or login correct, maybe? Okay, it looks like login successful works. And now all we need to do is follow the TCP stream, and we'll see that password 123 was the password that allowed the attacker to successfully log in through FTP to the victim, right? So we'll go ahead and put that in, password 123. What is the current FTP working directory after the attacker logged in? Okay, so this will be after the attacker officially logs in, right? So what we want to do is we want to actually retype in FTP contains login successful. I spelled successful wrong. There we go. And we want to look at probably the second packet, right? Because that's going to probably be the official packet that it logged in with. So let's look at 395. We'll clear the filter first. So after that, we'll see, aha! So the attacker actually types in PWD, and that stands for print working directory. So why don't we go ahead and follow this TCP stream instead? And we'll see, okay, this command was typed in, and it looks like the response back says var www html. So that's going to be our answer for the working directory. And PWD stands for, I don't know if I already mentioned that, it stands for print working directory. So the attacker uploaded a backdoor. What is the backdoor's file name? Okay, let's see if there's anything else in here. Yes, it does look like he uploaded something called shell.php right here. And that's what the STOR is doing. It is basically taking something from his remote machine and putting it on, or uploading it through FTP to this machine, right? So we're going to go ahead and just say shell.php because that is clearly what we're looking for here. The backdoor can be downloaded from a specific URL as it is located inside the uploaded file. What is the full URL? Okay, so now we're looking for some HTTP information, which is not going to be available here. But what we can do is clear the stream again, and we can come down to where we actually have HTTP requests being sent. So why don't we go ahead and just follow the TCP stream here? We could have also followed the HTTP stream, but this is easier because here we have the option, and unlike with following HTTP stream, we can just cycle through the streams. If it was downloaded through HTTP, we should be able to see the contents of the file through however it was downloaded, right? Because whenever you get a response back from a GET request, you'll see the data should be transferred. And we saw 80 earlier being used, right? So it's not encrypted, so it should just be in plain text. So if we know this happened prior, right? So if we back it up, here we go, PHP reverse shell. And it's looking for a specific URL it can be downloaded from. And if you look down right here, you'll see that this reverse shell was downloaded from pentestmonkey.net, which is a website that lets you that has shells and other, penetration testing tools available for you to use. So we'll go ahead and put that in. Which command did the attacker manually execute after getting a reverse shell? So we know here, right, the shell was grabbed and then at some point it was executed. So the attacker got a reverse shell, which basically means they have access in the system. So it only follows that in one of the next streams, we're actually going to see that command information that he's typing in. And lo and behold, the next stream up from, all the shell stuff is his commands, right? And the first one he did after getting his reverse shell looks to be who am I, which basically tells you what your user is, right? And we can see here that it responded back with www-data, which is the basic Apache web user, right? What is the computer's host name? We can clearly see that the computer's host name is down here where it says Jenny at wire in late speak, right? So Jenny is the user and wire is going to be the host name of the machine. So we're just going to grab that. Oh, it's also right here, right? Before they switched user to Jenny, you also have it here, and don't see it anywhere else up here. and that's because they spawned this. What they did was they spawned an official bash shell, right? And when they did that, it allows them to actually have a proper shell to work with. Like, because before they had a very generic shell, and it has some flaws in it that doesn't allow you to do certain things. So getting a proper shell gives you the ability to actually type commands in as if you were actually at the computer yourself doing this, right? That's what the attacker wants. And that's the whole point behind this spawn shell right here. So we're going to go ahead and take wire3 or wire as the computer's host name. And which command did the attacker execute to spawn a new TTY shell? And that's what I was talking about. Or that's this command here that they use to get, you know, a nice bash shell, a clean one that they can run all their commands on without it bugging out or whatever. Which command was executed to gain a root shell? So that's going to be, we scroll down, sudo su. What sudo su does is it switches you to root. So that's that command. The attacker downloaded something from GitHub. What is the name of the GitHub project? If we look a little bit further down, we'll see the GitHub project right here. So this is Forbidden would be the author of the project, and Reptile would be the name of the project. The project can be used to install a stealthy backdoor on the system. It can be very hard to detect. What is this type of backdoor called? We know that the backdoor was installed in root, right? Because if we look here, when the attacker got root, that's where he cloned his project in, right? So that's probably where he's putting all his malicious stuff in. And if you scroll down even further, right, we'll see that he's going into the Reptile folder and he's doing make, right? So all of this stuff is being done in root. And a lot of times when hackers drop these files into root, they're a lot of times very hard to detect because usually the operating system by default trusts root, right? Because it is literally the super user of the system. Like I said, it's a great way to hide certain things, and the specific one that is typically hidden there is called a rootkit. And a rootkit is essentially what it sounds like. It's literally a hard to detect piece of malware that basically he's trying to maintain persistence with the system, right? And as long as this rootkit is here, he's going to have that connection he needs to get back into the system without having to do all this other stuff to it, right? So, and it's also probably sending information back to whatever server he's associated with, right? We don't know what's in the project. We could go and look if the project even exists. There's no point in doing that, though. If you want to do that, you can if you're interested. But for the sake of this, we're going to say rootkit. And that was the right answer. All right, so that was task 1. Task 2, hack your way back into the machine. All right. So for this one, I'll go ahead and leave this information up because we may need it again. In fact, the first part says the attacker has changed the user's password. Can you replicate the attacker's steps and read the flag.txt? The flag is located in the root reptile directory. Remember, you can always look back at the .pcat file if necessary. Okay, so we kind of know based off task 1 what the flow is for this one, right? Like what process we need to follow to do this. We're basically just going to do the same things that the attacker did, right? So let's go ahead and start our machine up, and we'll have to start an attack box up as well. And I'll maximize that. And I'll get back to you when all that's loaded. Okay, our attack box is finished loading, and our target box has also finished loading. It looks like our IP address is 10.10.152.216. So let's go ahead and get started on the next part. We already read this part, I think. Yeah, we did. So we'll go ahead and complete that. Run Hydra or any similar tool on the FTP service. The attacker might not have chosen a complex password. You might get lucky if you use a common word list. Okay, so it appears that the attacker changed the password, so password 123 is not going to work, right? Let's go ahead and launch a terminal up and maximize that. So it's basically saying, hey, we need to run Hydra on this, right? So let's go ahead and do Hydra tech H. and see how we can use it, right? So it looks like we need a login, and we know that's going to be Jenny, right? We could log in as root technically, but the password's not going to work for root, right? We need to log in as Jenny and then elevate to root. Unless root has its own password that we can use, which we don't know what that could be or if they're even... Anyways. And then attack P for pass, all right? So, oh, we got some example usage down here. Oh, okay. So we're probably gonna wanna use a pass list, and you already know the famous one of all, rockyou.txt. So we're gonna go ahead and see where that's located in our Kali box, okay? It's located in its usual place. So let's go ahead and run it. Hydra, attack L Jenny, attack P, user /share /wordless, rockyou.txt. And then the way that we're going to actually target this IP address is through FTP, right? And the way to do that is just same thing as how HTTP is referenced in a browser, right? You're gonna do FTP : // and then the IP address. And then we're gonna chill here and wait for that to finish. Okay, it looks like we got a password back, 987654321. All right, easy, easy, easy. Okay, so I guess we'll just go ahead and complete that. Change the necessary values inside the web shell and upload it to the web server. Okay, so we're gonna go ahead and log into our victim box. So FTP 10.10.152.216. Okay, so we're gonna say Jenny, and then 987654321. All right, and we're in. Let's go ahead and see what directory we're in. You can do pwd, yes. Oh, so we're in the web sources directory. So all we need to do is literally modify shell.php in there. Simple enough. Let's go ahead and do a get shell.php so we can grab it to our own system. And then we'll do a new tab. And see, there it is right there. So let's go ahead and run nano on it. And oh, one thing, so it looks like we need our IP and the port we're going to be targeting. So we definitely don't want to do 80. Let's do 444. All right, that's what Metasploit uses by default, I think. And then we do need to change the IP. First, we need to find the IP. So let's open a new tab. Let's run ifconfig on our machine. And we want the 0 right here. This will work. Copy that. Paste it there. All right, we should be good to go on that end. Now, the other thing we need to do is open up a netcat listener so that when we do upload it, and the way to obviously run the script is by navigating to it in the browser, right? Or some other means, right? And if you navigate to it through the browser, the Apache server will execute it, right? Because it is a PHP script on an Apache web server, for the backend anyways. So let's do nc task in lnvp, something like that, and then do 444, and that's gonna open up a local listener for us. So, and that's what the script's going to call back to once we execute it, right? Because we set the IP and the port in the script to our ones that we want to listen on, right? Okay, so we can come here, and I think it's, let's see, I believe it's put, right? Yeah, so we're gonna put shell.php back in. All right, ls. Okay, so now we should be able to just navigate to it and it executes. So let's go ahead and open up our browser. Should be 10.10.152.216. All right, there's the Apache backend. Okay, so we can confirm that we do have a connection to it, and we want to run shell.php. And the reason we can just do /shell.php again is because it's right inside the var www.html source, right? So we can get right to it, just like how index.html is right there. So if we go back to our netcat listener, we should see that we have an interactive shell going right here, right? And of course, we can do the usual who am I, right? We're www-data, just like the attacker was previously, right? We're basically just retracing with a few tweaks here and there the tracker steps and just basically following in his footsteps, right? Just getting in the same way he did. It's his fault that he made the password arguably even weaker than the last password the password that Jenny set, right? Very generic passwords that are easily guessable to an extent, right? Change the necessary values inside the web shell and upload it to the web server. We did that. Create a listener on a designated port on your attacker machine. Execute the web shell by visiting the .php file on the targeted web server. We just did that. Create a listener on the designated port on your attacker machine. Execute the... Become root. All right, so if we go back to our source here, we can follow and see what the attacker did to become root. Sudo tac l is going to tell us all the sudo commands we have, right? Actually, first what we want to do, of course, is give us a nice shell to work with. So let's go ahead and... Oh, we can't copy that in. We'll have to type it in. That's right. So it's going to be Python 3 tac c port pty on okay, and that should work for us. Yep. See, now we're www-data at wire, right? So let's go ahead and switch user to Jenny. We know the password 7654321. All right, because we know Jenny has sudo abilities based on what the attacker did, right? See, when you log in as Jenny, you have access to sudo, which is very important. www-data, the base web user, does not normally, unless set up to, by default, it does not have sudo permissions. Now, if we do sudo tac l, it'll show us, we gotta do the password again. Show us all the things that we have access to as far as sudo is concerned, right? In the end, that doesn't matter as much, and here's why. Because we can just do sudo su, and we logged right in, right? Didn't even prompt us for password because we already typed it in. So Jenny has the ability of a super user, so she can elevate to root whenever she wants, as long as she uses her own password to do so. So now we're root, and now we can complete that task. And it looks like the final question, which is actually the only one in this task where we actually have to answer something, read the flag.txt file inside the reptile directory. Now, if we remember, the flag is located in /root/reptile. So let's do ls. We need to go to root. And then, yep, there's reptile. We'll go in there. Oops. Well, the tab complete kind of was a little wonky there, but it still took us in there. And there's our flag.txt right there. Cat flag.txt. We'll take that. Boom! We completed the room. All right. If you enjoyed the video, drop a like, subscribe to the channel to show your support, and also don't forget to turn on post notifications. That way you can be reminded when we drop new videos. Check out our Discord and Patreon links in the description box down below. And leave any feedback or questions in the comments section down below. This is Almond Milk. Thanks for watching. Goodbye, world.